So, welcome again to the lecture series of communication system. In this lecture series, I am going to discuss about the random variable. See, this particular random variable is nothing but a rule or function that associates a number with each outcome in a sample space. See this particular diagram, space is given in the omega, and there the some number that exists between the -1 to 1. So this particular number is associated with the outcome in the sample space. So this particular sample space, we are considering some of the points. That particular point is associated with a number given. So see the explanation is, suppose that to each point of a sample space we assign a number. We then have a function defined on a sample space. So these are called the different functions in a sample space. This function is called random variable, or more precisely a random function. This random function is also called stochastic function. It is usually denoted by a capital letter such as x and y. In general, a random variable has some specified physical geometry or other significance. So there are two types of the random variable. First is the discrete random variable, another one is continuous random variable. So discrete random variable has countable number of the possible value. See here, we assign we assign number to the function. So is have a countable, because in -1 to 1 there is two possibility. Either we consider infinite number of the point, or we consider some finite number of the point. So if we consider some finite number of the points, then it is called a discrete random variable, and if it is an infinite number of the points, then it is called continuous random variable. Or we consider, if we consider all the value in an interval, then it is called continuous. Or if we consider some particular number, then we have called it a discrete. So a random variable is continuous if possible value comprise either a single interval on the number line or a union of disjoint intervals. Example, if in the study of ecology of a lake X, the random variable may be the depth measurement at randomly chosen location. See here, it is a depth measurement at randomly chosen some location. So if we consider the number of the location, it has the some discrete number, but the x is actually represent the depth. So depth have a variation from the maximum depth to the minimum depth. So x is a continuous random variable. So the x is a continuous random variable. The range for x is the minimum depth possible to the maximum depth possible. In principal variable such as height, weight and temperature are continuous. In practice, the limitation of our measuring instrument restrict us to a discrete world. However, continuous model approximate real world situation very well, and continuous mathematics is easy to work than mathematics of discrete variable and distribution. But so what is the random variable? So they suppose the variable x of interest is the depth of the lake at randomly chosen point on the surface. So the m is maximum depth, so that any number in the interval 0 to m is a possible value of x, because 0 is the minimum and m is the maximum. So if we discretize x by measuring depth at nearest meter, then possible value or non-negative integer, then less than or equal to m. So in the case discrete, let x be a discrete random variable, then the possibility the function fx equal to px, where x is equal to small x, it is a 0. This particular x is basically a function of a sample space. So either it is px or it is a 0, any probability, or it has 0. So in case of the continuous, if x is a continuous random variable, then the probability density function of x is a function fx such that for any two number a and b with a is greater than b. So see here in this figure the distribution is like this in the case of continuous variable, and here the probability of x between a to b is integral a to b fx dx. It means area under this particular curve. So the continuous random variable a fx equal to probability of x less than equal to x, and this probability is nothing but the area minus infinity to infinity minus infinity to x fy dy. So it nothing but it is the area under this particular curve is called the any value. So similarly, expectation of a random variable or the mean of the random variable is represented as the mu x, and it is the summation of x into fx. So that is called the mean. And similarly, the expected mean or value of the continuous random variable, it is minus infinity to infinity x into fx. Here in the case of the discrete it is a summation, in the case of the continuous it is a integral sign. Then in the case of the variance, again it is the summation of x minus mu. We know that x is the actual value, mu is the mean value. But in the case of continuous, it is the integral of minus infinity to infinity. So it is the mean square value. So it is x minus mu square. So we know what is the mu and we know what is the x. So in general, we write e x minus mu whole square. Similarly, here we also write x minus mu whole square, but it is value is minus infinity to infinity in x minus mu whole square dot fx dx. So that is the difference between a discrete and random variable in the case of the variance of the random variable. Then our next is the probability density function. Let x be a continuous random variable, then the probability distribution or probability density function of x is a function of fx such that for any two number a and b, we have probability p x x is varies from a to b is equal to a to b fx ds. The probability that x is a interval a and b can be calculated by integrating the PDF of the random variable f. It means the PDF is p fx in dx is called probability density function. So that's all about today lecture. In the next lecture we have discussed about the cumulative distribution function and all other random variables. So thank you.